Chapter 12.1, Explore Solids. So the main thing we're going to be learning is about polyhedrons. Okay, a polyhedron is a solid that is bounded by polygons. All right, let's go to the diagram. All right, so this right here is a polyhedron. Notice it consists of polygons. Okay, so each polygon is called a face. You can see that highlighted right here. Each polygon that makes up the polyhedron is called a face. All right, and an edge is a line segment where two faces meet. So if I can highlight an edge here, something like this right here, that would be an edge. All right, something like this right here, that would be an edge. So it's just a line segment where two faces meet. And finally, a vertex point, that is a point where three or more edges meet. So any of these points on the polyhedrons, those are vertices, or the singular is vertex. All right, so these are the types of solids. On this side, we have polyhedra. All right, and why are these polyhedra? Because they are only consisting of polygons. All right, so this right here is a prism, and this right here is a pyramid. Notice that the pyramid, it comes to they all meet at a certain point, at a vertex. And these are not polyhedra. Why are these not polyhedra? Because they're curved. Okay, when you have a curved surface like a circle is not a polygon. Remember, a polygon has to have at least three sides. So these are not polyhedra because of the curved surfaces. All right, so you want to remember to name a prism or a pyramid, use the shape of the base. So let's take a look. All right, so right here we have a pentagonal prism. All right, so why is it called a pentagonal prism? Because the bases are pentagons. All right, remember that a pentagon has 5 sides. So if you look at the bases here, we have 1, 2, 3, 4, 5 sides. All right, so that's a pentagon. And same with the bottom part. 1, 2, 3, 4, 5 sides. So the top and bottom, they are both pentagons. All right, and the bases, this is for a prism now, the bases are both parallel and congruent. Okay, so the pentagon on the top and the bottom, they are the same size, they are congruent, and they're both parallel as well. If they extended forever, they would never intersect. All right, so the prism is named after its bases. So in this case, it's a pentagon or pentagonal prism. All right, and remember we said for the pyramid, the faces meet at a point. See, they meet at this point right here. And this here is a triangular pyramid. Why is it a triangular pyramid? Because the base is a triangle. Well, you can see right here on the bottom, the base of the pyramid right there is a triangle. All right, so the base of a pyramid is a polygon, and the pyramid is just named after its base. Since it's a triangle, it's called a triangular pyramid. All right, example 1. Tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. All right, let's start with part A. All right, think about part A and see if you can name what kind of polyhedron this is. All right, this is definitely a polyhedron. It doesn't have any rounded edges. All right, and it's not a pyramid because it doesn't come to a point like part B here. So this is definitely a prism. All right, and what kind of prism is this? Well, just look at the bases. We can see the base here. It has a right angle, and opposite sides are congruent, but not all four sides. So this is clearly a rectangle. Okay, so you would call this a rectangular. Let me fix this. This would be called a rectangular prism. All right, so then we want to find the number of faces, vertices, and edges. Let's start with the faces. All right, so see if you can figure out how many faces this has. So for the faces, we have one on the top, we have one on the bottom, we have one on the right, and we have one on the left. All right, so that's going to be 4. And then we have one in the front, and we have one in the back. All right, so 4 plus 2 faces, that's going to be a 6. All right, so 6 faces. Let's see if we can count the vertices. All right, see if you can count the number of points or vertices. Well, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8. All right, there's no other points, so that's it. 8 vertices. All right, and finally, edges or segments. So let me clean up the diagram. All right, see if you can count the number of edges or segments. All right, let's see. We have 1, 2, 3, 4. 4 so far. And then we have 5, 6, 7, 8. And then in the back, 9, 10, 11, 12. All right, so that is 12 on the edges. All right, so that's for a rectangular prism. All right, please pause and see if you can name the figure in part B. So these all meet at a point. All right, so this is definitely a pyramid. Let's count the sides on the base. We have 1, 2, 3, 4, 5, 6 sides. What do we call 6 sides? That's a hexagon. Okay, so the base is a hexagon. So this is going to be a hexagonal pyramid. All right, the pyramid meets at a point, and the base is a hexagon. That's a hexagonal pyramid. All right, see if you can count the number of faces. Well, let's see. We have the one on the bottom here. All right, that's one of the faces. And how many triangles we have? I'm thinking 6 because we have 6 sides, right? We have a triangle right here. That's 1. On the left, that's 2. Right here on the right, that's 3. And then in the back, 4, 5, 6 right there. All right, it only makes sense if the hexagon has 6 sides that there's 6 triangles. All right, because it's a hexagon. And then if you count the bottom, that's going to be 7. All right, so faces, we have 7. If you can't see it, just remember that it's a hexagon. And for each side of the hexagon, it has a triangle that connects to that point on the top. All right, so it has 6 of them, and then the bottom counts as number 7. All right, see if you can count the number of edges, please. Edges on the bottom, definitely 6, right? 1, 2, 3, 4, 5, 6. So we definitely have 6 on the bottom. And then the edges that connect to the point, I think there has to be 6 of those as well. Yes, it has to be. 1, 2, 3, 4, 5, 6. How did I know there were 6? Because the hexagon has 6 sides, and if it has 6 sides, it has to have 6 points or vertices. All right, so it's going to be 6 plus 6 for the number of edges, which of course is 12. So the number of edges is clearly 12. All right, vertices are the points. That's pretty easy. See if you can count the vertices, please. All right, we have 1, 2, 3, 4, 5, 6, 7. All right, that makes sense. A hexagon has 6 sides. It's going to have 6 points, and then 1 extra point on the top. So that is definitely a 7 for the number of vertices. All right, think about part C and tell me if it is a polyhedron. All right, part C, the answer is no. It is not a polyhedron. All right, who can tell me why? Who can tell me why it is not a polyhedron? Well, it has a curved surface. All right. It has a curved surface. You can't have curves, you can't have circles. A polyhedron has to be polygons only, okay? Polygons are 3 sides or more. They consist of line segments. They do not consist of curves or circles. So this is not a polyhedron, so we can't do the other steps. All right, in number 1, see if you can just name this polyhedron. All right, notice the base. It has 4 congruent sides, and it has a right angle. So that base is definitely a square. Okay, and they all meet at a point. So that makes it a pyramid. All right, try number 2. Can you name it? And if not, explain why not. Okay, we can't name number 2. This is not a polyhedron. All right, and why isn't this a polyhedron? Because it has curves. All right, you can't have curves for a polyhedron. Last one, number 3. See if you can name it. All right, notice this part right here. That's clearly a triangle. And now in the back, right here, we have the exact same triangle. How do I know? Because this is marked congruent to that. This is marked congruent to that, and we have right angles. So this is definitely a triangular prism. Okay, the pyramid, they all meet at a point, but the prism, it has the same base, matching bases, okay? So those are both triangles, and that's why it is a prism. All right, so this is Euler's theorem. It's not pronounced Euler, it's pronounced Euler. Euler's theorem, the number of faces, vertices, and edges of a polyhedra are related by this formula, F plus V equals E plus 2. Okay, it's a very simple formula. F is the faces, V is the vertices, and E is the edges. All right, so this is the formula for any polyhedron. All right, so let's try a couple examples. For each polyhedron, use Euler's formula to find the missing number. All right, let's look at part A. All right, so the formula, Euler's formula, F plus V equals E plus 2. F is the number of faces. E is the number of edges. V is the number of vertices. All right, so they gave us 2 out of 3. See if you can plug in and solve for F, please. All right, we don't have F, so I leave that alone. And that's plus V. V is 20. And that equals E. E is 30. Plus 2. Okay, all I did was use the formula and plug in the numbers. It's pretty simple. I plugged in the numbers that we were given in the formula. I'm going to solve for the third, which is F. Okay, we have F plus 20. The opposite of plus 20 is minus 20. All right, I'm just doing algebra 1 here. 20 minus 20 cancels. Bring down the F. Bring down the equal sign. 30 plus 2 equals 32. And then 32 minus 20 is 12. So that's it. The number of faces is just 12. And that equals F. All right, see if you can answer the same type of question in part B. All right, so let's see. Faces is represented by the letter F. Edges is represented by the letter E. Vertices is the letter V. All right, so faces, F is 20. V vertices is 12. And that equals E plus 2. All right, once again, I am just using the formula and plugging in for the numbers we were given. 20 plus 12 is 32. And that equals E plus 2. All right, solving for E, the opposite of plus 2 is minus 2. 2 minus 2 is gone. 32 minus 2 is 30. And that equals E. The number of edges is 30. All right, pretty simple. Just use Euler's formula.